One of the many challenges for the fresh fruit and vegetable sectors is waste through spoilage post-harvest. But as a result of a combined effort between Plant and Food Research and Edison Derby, a commercial-scale inline scanner incorporating dual lasers and AI is being developed to help address that. As Dr. Andrew McGlone explains, there's a lot to be gained from this work.
It's a $4 billion industry New Zealand has, and it's a lot at stake if poor quality fruit goes offshore, leading to a lot of wastage in foreign markets and so forth. So we at Plant and Food have had a mandate to research non-destructive testing techniques to assess the quality of fruit. So fruit can be segregated, and the fruit that might end up as wastage in the supply chain and in the marketplace doesn't happen, isn't wasted. Defective fruit that have problems inside them that will transpire to become major problems in the marketplace, like incipient rots and so forth. Getting rid of those early prevents a lot of wastage in the supply chain. That's a true advantage of non-destructive testing. If you can find those small rots or small problems that aren't going to be a problem over a short term, you can ship them early and they can be sold, and the quality of the fruit can be preserved in the marketplace, the value of it, as opposed to letting it sort of develop into a major rot and become a problem later on. Our markets are a long, long way away. The big, valuable markets in the Northern Hemisphere, and we need to be able to sort our supply chains out and get stuff to market quick. The cost of shipping New Zealand fruits, it's high, and we have to get good value for our fruit, much higher value to cover those costs, those shipping costs. Yeah.
Dual laser system uses lasers as the light source, providing high power and ability to focus into a small beam. The other aspect about laser is that they are monochromatic. So our research has found out the useful wavelengths that it is sensitive to the internal defect of interest.
We've had to be clever, because when you put light into a fruit, it becomes very diffuse. It's like shining a torch on a foggy night. You don't see very far, so you've got to be very particular about the wavelengths of light you use and where you put your light in and where you pull it out. And we've got the other challenge of having to operate very quickly. We've got to make a measurement within about 10 milliseconds to 100 milliseconds. So we've got a system here with some lasers that we collimate them and direct them down onto the fruit, and then we have some sensors that pick up the light that gets through the fruit and tells us where the defect is.
The objective is to create a multifaceted, sensor-based AI model for sorting, at this stage, onions and apples. The methodology we're using is using a wide range of multispectral light to identify and classify size, shape, internal defects that are close to the surface, and make sure that the customer can pack fruit to the highest possible standard. The connection with Plant and Food Research with the dual laser platform allows us to actually add another sensor methodology, so we get a richer data set and we can make better decisions in order to identify where and how that product should be packed. The key feature that we've been looking for, and why we're so excited about the dual laser, is it allows us to look deeper inside the fruit than we've previously been able to do with any of these sort of multispectral vision techniques. These techniques have been around for a long time. They've been evolved and advanced, and AI technology has improved a huge amount. When we start to fuse different technologies together into a fusion model, that's where we're really excited about what we can do with this, and that's where the collaboration between the two entities really start to build something quite special and quite cool. We were trying to develop a next generation grading platform. We became aware of some of the work that Plant Food Research had been done based on some of our earlier relationships with previous entities we've been working through. We knew that they had a deep understanding of some of their biological testing and validation of all the wonderful things they do. So when we knew where we were going, it seemed to make more sense to partner with them rather than necessarily try and reinvent something from scratch. So then fusing the two things together just provides a more logical endpoint for everybody. So this is our base Kailu platform. So Kailu is custom developed for each category we work on. At this stage, we've got our first deployment at a customer at Tuakau doing onions. With onions, we'll do size, shape, the defects, blesher, pipers, all sorts of interesting things. This is showing real-time onions that are under the cameras right now with the AI model actually operating. We use this to test and validate that the decision making is consistent. And then when we start to add the dual laser component, it gives us another data set we'll build on top of it. So together they come and make a complete offer, so that we can get just more complete understanding of where we're going with different crops and commodities. There's a lot of people who have made huge investments into this industry already with other different grading platforms and technologies. You know, a lot of those big heavy pieces of metal, they don't wear out, they don't go away. So what we're doing is we're repowering that stuff. Some of the great AI engines that are floating around, with the custom lighting that we build for each category and the models we train with it in correlation with our key customers. You know, it just means that we're not asking our customers to spend a whole bunch of money or waste a whole bunch of investment they've previously had. So it's an upgrade. It's designed to improve and enhance what they've already done without necessarily costing them a full recite. We work through the commercialisation process, making sure that we find a market globally for it, and then help them build products that are able to be manufactured efficiently, built in New Zealand, and delivered internationally. So it's taking a team that's got a lot of experience that have all come with me and really building something that's quite special, I think, for New Zealand.